Good morning. We're here at the ESCRS in Vienna, Austria, and we're pleased to have Dr. Warren Hill from Arizona. Thanks very much for being with us today.
Oh, it's my great pleasure.
Warren, I know that you're having some very interesting presentations at this meeting, specifically about the next generation AI formula, a 2.0 formula, if you will, on regard to the Hill-RBF. Can you explain where we've been with this artificial intelligence type formula and where we're going next?
Sure, great question. Well, as we all know, artificial intelligence is a big data exercise. And when we began, we had about 3,400 cases that were vetted and we knew were correct. We were able to, from that, make an artificial intelligence model. And now we've moved up to about 12,400 cases, and we now have an artificial intelligence model with a greater breadth and depth to increase the accuracy and also the number of inbounds calculation cases.
I'm glad that you brought up the term inbounds, because sometimes when we run this formula, we receive an input that says out of bounds. What exactly does that mean, and how do we interpret that information?
Well, for this type of calculation, we have four variables: axial length, central corneal power, anterior chamber depth, and the spherical equivalent we want. And from that, we generate 6 pairwise boundary models. When you have an out-of-bounds calculation, it means that we don't have a data point within each one of those 6 pairwise boundary models. And the pairwise boundary models are calibrated to a 90% plus or minus half a diopter. So when you get an inbounds indication, it means you have a 90% chance of being within half a diopter. Doesn't mean you can't use it, it just means that we can't predict the accuracy, and probably using that value is not recommended.
Mm-hmm. That's a great point. I want to go back for a moment and talk about some of the variables that we do input into our formulas. Right now we're using variables such as axial length, which has gotten quite a bit better with optical biometry, but one of the other main variables is corneal curvature, which is still not as reliable as we'd like it to be. What are some of the limitations there?
Well, of course, reflective keratometry is from the middle of the 19th century. I'm sure we're doing better now than we did back then, but it's still, from my perspective, is one of the noisiest inputs we have into the whole calculation process. So in order to get much better outcomes, we need a lot better measurements, and first on my list is the cornea.
Where do you think that we might go with corneal measurements in the future?
Well, I think we need to be able to measure both the anterior surface, the sagittal thickness, and the posterior cornea, and of course swept source OCT is a really good candidate for that. There's still some technological limitations that need to be overcome in that area, but I think once those have been mastered, I think we're going to see an increase in accuracy for the overall measurement process.
Let's talk for a moment, Warren, about some of the clinical applications of the artificial intelligence formula, specifically about the challenging cases of both short and long eyes. I think that, as you and I have spoke about before, many of the formulas can really get a very good estimate for normal length eyes, for average length eyes, but it's the extremes of very short and very long eyes where we have the most challenge. Can you speak to the way that the artificial intelligence formula handles these scenarios?
Sure. Well, let's back up just a little bit. For the very long eyes, thanks to Lee Wong and Doug Koch at Baylor University, we've been able to conquer that even with some of the older formulas like Holiday 1. The Barrett Universal 2 formula does a wonderful job for long eyes, and Hill-RBF also does as well. So for the long eyes, what used to be one of our most problematic cases where we had to pick a pretty myopic target to avoid a hyperopic outcome, we pretty much conquered that to within our own expectations. The short eye is another issue. The short eye still gives us a wide range of outcomes, especially the unpleasant myopic surprise. When we've been looking at outcomes using Hill-RBF, what we found is that for the short eye, Hill-RBF is now doing probably a better job than just about anybody else. So it's a different calculation methodology, and we're now seeing different outcomes as well.
Well, this has been really a terrific summary for us about where we've been with the AI formula, and to see how the database for the AI has grown and grown over the years. It's great to see the incremental increase and the great outcomes that we're having. Thank you so much for sharing your expertise.
Thanks for your time.